Welcome to Scoop and Scale, where we dish up the science and weigh the facts about mostly equine nutrition. I'm Jill Jackson, lifelong equestrian, podcast producer, and pony owner. I'm a dressage rider and at-home horse keeper, living the challenge of managing easy keepers on multiple acres of pasture.
And I'm equine nutrition consultant, Dr. Claire Tunis of Clarity Equine Nutrition. I develop diet plans for horses ranging from metabolic seniors to Olympic athletes. I also consult for equine nutrition companies. I'm a scientist, dressage rider, and pony club mom.
Claire and I have been horse friends for almost 20 years, and like all good horse friends, we're always talking horses. We talk about the challenges of managing our horses, our riding struggles, feeding horses, and what's going on in the wider equine community. This podcast is a place for us to have conversations mostly about equine nutrition. It's for anyone who wants to make better choices when it comes to feeding their horses.
And before we get started, a quick disclaimer. The information in this podcast is general and not meant to replace the individualized advice of your own qualified equine nutritionist or veterinarian. And while I have a PhD in nutrition, I'm not a veterinarian and can't give medical advice.
With that, thank you for joining us, and we hope you enjoy the following episode.
Aminos are a topic that come up in the online groups quite frequently.
They're everywhere. I just did a quick search in Facebook for aminos, and these are just a couple of the questions I found. If you want to make sure your horse is getting all the aminos without extra calories, what are you giving? What are your favorite pure aminos?
These are kind of interesting questions, right? They're endless, like these questions. I mean, we just see them all the time, right? I mean, they're just aminos, they're everywhere. Everyone wants to know about aminos. And so today we thought we would clear the air about these elusive aminos, which, by the way, is actually just a short-term phrase for amino acids.
Yeah, let's just call them amino acids instead of aminos, like they're a thing. Or that you sound like you don't know what you're talking about because everybody else is calling them aminos, so you're just calling them aminos so that you can learn about them. They're amino acids.
So let's actually learn about them.
Let's do that. Let's start basic. I know protein is made of amino acids, but I'm sure that there is more to it than that.
That's actually kind of the whole concept in one sentence. So amino acids are the building blocks of protein, right? So if proteins are words, amino acids are the individual letters. And horses don't really have a protein requirement in the way that we usually talk about it on a feed tag. What they actually need are amino acids in the right amounts and the right ratios so the body can assemble them into the specific proteins it needs.
Muscle is one of those proteins. What else is built out of amino acids?
So anything that's a protein, right, is made up of amino acids. So muscle's the one that everyone thinks about because we're always wanting to build top line, right, and have strong, healthy muscles. But hooves and hair, they're made up of the structural protein keratin. Enzymes are proteins, a lot of hormones are proteins, antibodies, collagen in tendons, ligaments, and joint cartilage, those are all proteins. Even hemoglobin, right, the molecule that's carrying oxygen in our blood, needs specific amino acids to fold correctly. So amino acids are everywhere.
So when someone says I'm feeding aminos for top line, what's happening biologically?
So muscle tissue is constantly being broken down and rebuilt, right? Like that's just normal turnover, and it ramps up when we exercise. So to rebuild it, the horse needs a full supply of the amino acids that make up muscle protein in the right proportions, arriving at roughly the same time, right? So even if one required amino acid is in short supply, protein synthesis for that structure gets capped. You have plenty of everything else, but it doesn't matter because you don't have that one particular amino acid that you need to keep building.
Before we get to supplements, what's actually delivering amino acids in a typical diet?
Yeah, so forage first, of course, because it's a foundation of the diet and contains protein. And because it contains protein, it's going to give your horse amino acids too. However, forage quality varies a lot, and we talk about that in other episodes, right? So the amount of necessary amino acids can also vary. And then concentrates and feeds add more amino acids, and specific ingredients are included sometimes because they are a strong amino acid source. So they are in that feed for that reason.
Give me the usual suspects.
So soybean meal is the big one. It's the gold standard protein source in the feed industry because it's naturally well supplied with lysine, which is the amino acid horses tend to run short on. I think that it's unfortunate that some people can demonize soy because, they demonize it because it can be genetically modified. It contains estrogen-like compounds. And so, they have concerns about it. However, it is an excellent source of complete protein, and there's no hard science that these features that they're concerned about are a problem for the majority of individuals. So I think that's unfortunate when, you're really cutting out a really important source of amino acids in a horse's diet if you're avoiding feeding soy. But alfalfa is another one. It's better than most grass hays from the protein quality standpoint. So it's going to have more of some of the important specific amino acids. You'll also see canola meal as an alternative protein source, and sometimes whey protein or milk-based proteins in specialty feeds. And you'll sometimes see whey and young horse rations or feeds designed specifically for high-end performance horses because, again, they have excellent amino acid profiles.
And then there's the stuff that gets added as a pure ingredient, not as a whole food. Right.
So that's the sort of crystalline or free amino acid category. So you might see that on a label as L-lysine, D-L-methionine, L-threonine, L-tryptophan. Those would all be examples. These are manufactured, highly purified individual amino acids added directly to the feed or supplement in specific gram amounts rather than coming along for the ride inside of a protein source in something like soybean meal.
Why would you use a purified one instead of just feeding more soybean meal?
Precision, mostly. Okay, so if a diet's just slightly short of one amino acid, you don't need to add a whole scoop of extra protein, which raises calories, increases the nitrogen that then the horse has to excrete, and it costs more. I mean, protein ingredients are some of the most expensive ingredients that go into feeds. So if I just need, a few grams of, say, methionine, then it's often cheaper and easier to actually just put in those couple of grams of methionine, this pure methionine, the thing that's actually missing to fix the gap directly, rather than having to put in a lot more total protein to get that amount of methionine.
Essential and non-essential are terms I hear thrown around constantly in regards to amino acids. What's the difference there?
Yeah, it's an important thing to understand, and it comes down to whether the horse's body can make that amino acid or not. So non-essential amino acids, like any other non-essential nutrient, can be synthesized internally. The horse's own metabolism builds them from other building blocks. So as long as the overall protein and energy intake in the diet is adequate, deficiency isn't really a practical concern because if it's not present in large enough quantities in the diet, the horse will take bits and pieces of other molecules and create that amino acid themselves.
And what does essential mean?
It means that the horse can't synthesize it, right? So they can't make it, and so it has to come from the diet. So we use the word essential in terms of all kinds of nutrients that the horse can't actually make, and therefore must be in the diet, right? So there's no metabolic pathway to manufacture it from scratch. And so if it's not being fed, it's not available to the horse.
So when people talk about essential amino acid supplements, that's the category they mean?
Exactly, right? So there are 10 amino acids considered essential for horses. They're lysine, methionine, threonine, tryptophan, leucine, isoleucine, and valine, phenylalanine, histidine, and arginine. Right, so everything else, for example, glycine, alanine, glutamine, proline, they all fall into the non-essential category that the horse can produce on its own. So we're really the most concerned from a nutrition standpoint in making sure that those 10 essential amino acids are accounted for and in the diet.
Does non-essential mean unimportant?
No. Non-essential isn't really a great name, right? Because it does sort of imply that it's not important. But it has nothing to do with the amino acids' importance. It just means the diet isn't the only source, right? They still do a real job in the body. It's purely a classification about synthesis capability, not about biological importance.
Of those 10 essential ones, which are we actually talking about when we look at a feed tag or a supplement label?
The horse needs all of them in the diet, like I just mentioned. But in practice, only a few are guaranteed in most products. And the reason is something called a limiting amino acid. The ones that run out first relative to what the horse needs based on what a typical diet actually supplies. So in horses, the first limiting amino acid is lysine, typically. And so it's the first limiting amino acid in almost every practical diet, especially the traditional diets of, say, grass, hay, and then the straight grains, the way we used to feed, 30, 40 years ago, straight, grass, hay, oats, and corn. That kind of a diet is going to be quite limited in lysine.
I've heard you talk about this in terms of letters and building words.
Yeah, it's a sort of easy to understand analogy, I think. So if you're trying to spell the word muscle, so if muscle is your protein, that's your word, and you run out of the letter U, it doesn't matter how many other letters you have sitting around. It doesn't matter if you have an extra E or you have an extra M, right? That's irrelevant. You need a U. So you can't finish the word. You can't spell the word muscle because you don't have a U. And that's essentially what a limiting amino acid does to protein synthesis, right? So the essential amino acid that's present in the lowest amount is going to impact the body's ability to make proteins. So for horses, the most commonly limiting amino acid is lysine.
And after lysine?
Methionine used to be considered second, but threonine is now generally considered the second limiting amino acid, particularly for growing horses. And then methionine comes in sort of in third place. So those three, right, the lysine, methionine, threonine, those are the trio you're going to see on, almost every sort of amino acid supplement out there. It's only in recent years that threonine has started appearing on feed tags. More commonly, we just used to see lysine and methionine being guaranteed. And that's still the case for some meat feed manufacturers. But more and more are starting to put all three on there. And I really like it when you see all three being guaranteed, because it gives me that sort of peace of mind that we're going to hit the requirements for those three, the three amino acids that are most likely to limit protein synthesis.
That just came up on Facebook. Somebody was saying, yes, and one of the questions that, I saw about the aminos, talking about the top 3 aminos. They didn't list the 3, but they knew that there was the top 3.
Well, that's a good start.
That is a good start. Anyway, what about tryptophan? I like this one. I see this marketed constantly, usually for calming. And that's because we all have Thanksgiving dinner and then we're really sleepy. So it must make our horses sleepy.
Yeah, not always. So there's some research out there that actually tryptophan, we should do a whole episode on calming, but I don't generally recommend a lot of calming supplements. And with tryptophan, you have to be a little bit careful because there are some horses that actually it has the opposite effect on. So, tryptophan doesn't always work as a calming agent, but it's, tryptophan is an essential amino acid. So it is, it's a building block for, protein synthesis, just like all the other amino acids are. But the calming claims are not well supported by control research in horses.
Anything else that shows up outside that main trio?
In performance and muscle building products, you'll sometimes see leucine on its own, or the branch chain amino acid group, which is made up of leucine, isoleucine, and valine. That's often, marketed for muscle support. You'll see that in things like muscle supplements for people, right, or recovery drinks. You'll quite often see, and you might see it abbreviated to BCAA, right? The BCAAs. Well, that stands for branch chain. You got your aminos and you got your BCAAs, right? And so the BCAAs are your branch chain amino acids. So if you're wondering what all these, slang is, that's what it is. But for the average horse, lysine, methionine, and threonine are the 3 doing essentially, the heavy lifting.
So is there research that tells us how much of these amino acids our horse needs?
The National Research Council guidelines, which are the guidelines we use for determining, they lay out what we believe the horse's nutrient requirements are. They only specify how much lysine a horse needs and assumes that a well-rounded diet that's providing enough lysine will in turn provide enough of the other amino acids as well. However, in other species, there's an interesting concept called ideal protein. And it's ideal protein is kind of a big deal in like pig and poultry nutrition. The logic is that if you know what ratio of amino acids a diet should supply, and you basically look at the ratio of amino acids found in tissue that you're trying to build. So let's say you're trying to build muscle. So in these, obviously in pigs and poultry, the protein that producers care the most about is muscle protein, right? Because that's the meat that they're going to sell those animals for. So they're very interested in the animal's growth rate and muscle development, and because that's their performance metric. So muscle is muscle. It has sort of like a known amino acid composition. So if you measure that composition, you sort of get a template for what the diet should look like, because the idea is you want the diet amino acid profile to mirror the profile of the tissue you're trying to generate. So in this case, muscle. Right. So we can use this concept in equine nutrition too, basing it off of the amount of lysine that we know the horse needs. So we know the amount of lysine, and then we from there sort of calculate the other requirements as well.
If you know the ratio of the different amino acids to each other in muscle, and you know how much lysine the horse needs, then you can figure out what they potentially need of the other amino acids. Am I getting that right?
Yeah, exactly. Right. So lysine becomes sort of the reference point, and you set it at 100%, and every other amino acid gets expressed as a percentage of lysine. So it's possible that, you could have something that's 110% of lysine, right? But lysine is sort of the anchor point. And so you're expressing as a percentage of lysine based on its share in muscle tissue. And for horses specifically, this was work done in like the early 1990s, where they first calculated the ideal protein ratio this way for horses. And then in about 2012, other researchers went further and directly measured amino acid profiles in muscle tissue, and then calculated the ratios from that real data. And luckily, they kind of compared quite well. So then in 2012, some other researchers went further, and they directly measured the amino acid profiles in horse muscle tissue and calculate the ratios from that real data.
Do those two agree with each other?
They do, actually, which is reassuring. It's always nice when, different research studies actually agree with each other. And so the ideal protein ratios from that earlier 1991 work and the work that was done in 2012 line up well with each other. And once you've established a lysine requirement, you can then use those ratios to estimate requirements for the other essential amino acids, which is genuinely useful because the other amino acids don't have their own dedicated NRC requirement the way lysine does. So some feed companies actually use this ideal protein concept to determine how much of how much methionine and lysine to put in their feeds, because there is no NRC requirement stated for any amino acid other than lysine.
Wait, so out of every amino acid a horse needs, we only really have hard established numbers for one of them?
Yes. I know it's worth sitting with that for a second, right? Because I think it's kind of surprising to people. I think we know a lot more about protein requirements in horses than we do. And certainly, I understand that like the NRC guidelines were published back in 2007, so almost 20 years ago at this point. And, there has been work done since then. Obviously, like I said, the work in 2012 that looked at the amino acid composition of muscle didn't exist when the NRC was written. So maybe that is something, if they ever write a new one, that we will get a methionine and threonine requirement. But at the time that was published, it didn't exist. And, if we compare that to, say, poultry and swine nutrition, they're decades ahead of us on this matter, right? Like in broiler and layer, production systems, and pig systems, individual amino acid requirements have been worked out one by one, like not just lysine, but they know every single methionine, threonine, tryptophan. They know most of the essential amino acids. They know exactly the requirement for every specific life stage. So it's different for a broiler starter diet than a grower diet, than a finisher diet. And, they have their own dedicated amino acid targets built from real dose response research done at each exact stage. So, they're light years ahead of us when it comes to protein nutrition in poultry and pigs.
And commercial poultry and pig diets are actually formulated around that.
They are. And so that industry formulates on a digestible amino acid basis rather than crude protein, because crude protein alone was recognized decades ago to be too blunt of a tool to formulate precisely with. And those species grow so quickly, right? Like, I mean, you used to raise chickens, right? Like chickens to get to market, it doesn't take very long to get a chick to market weight, right? So their protein requirements are, you need better data than just crude protein. Crude protein's too crude, for want of a better term, right? But equine nutrition is still, it's just, we've got a long way to go. And we have one well-supported number in lysine, and everything else gets estimated by sort of analogy rather than measured directly in the horse itself.
That's surprising given how many amino acid supplements there are out there making all sorts of claims.
Right? It's a much smaller industry with a lot less research funding behind it in, the equine space compared to, say, poultry and swine. Like the poultry and swine industries have this like massive global protein industry. They're a massive global protein industry, right? So they have way more economic incentive to dial in the nutrition to the gram, right? And again, like I mentioned earlier, protein ingredients are some of the most expensive ingredients that we put in feed. And so you want to dial it down precisely and not waste and get it wrong, right? Because you're just that's all going to be excreted out in urine and wasted. And so they really dial that down. Horses haven't had that same level of investment. So we're working with a thinner evidence base, and we're doing the best we can with ratios and educated estimates in the meantime. But like I said, we're nowhere close to those other industries.
I think it's really important for horse owners to understand the reality of our knowledge base, as it helps us to not get swayed. Like there's so much marketing out there that's too good to be true, on these supplements. Like it's good to understand what we actually know, what we're extrapolating from the data, and where the shortfalls could be. This actually leads into something I've wondered about. If lysine is the most commonly limiting amino acid, why not just dump a ton of lysine in and call it done? Because
protein synthesis doesn't work that way, right? Where one amino acid can cover for all the others, right? Building protein is more like a recipe. The body needs all the required amino acids present at the same time in roughly the right proportions to actually assemble that specific protein chain, right? So if methionine and threonine is sitting at half of what's needed, adding a mountain of extra lysine isn't going to help, right? They don't need the extra, they're not looking for extra lysine. They need methionine and threonine. So dumping a bunch of lysine isn't going to help that horse build more muscle protein. And the other two are going to be, they're going to be limiting the process. So now you just got a ton of lysine sitting there with nothing to do.
So the missing letter analogy again, more of the letters you already have doesn't help if you're still missing the one that you need.
Right, exactly. And there's a real cost to it too, because amino acids that show up without their partners present, like as I said, they sit around waiting, but they don't actually. Like the horse's body has to do something with them. You can't store amino acids beyond what you need, right? We just don't do that. And so we have to get rid of them. And that means you have to break them down. So the nitrogen from unused amino acids gets stripped off and excreted, mostly as urea. Which is metabolically demanding. We've talked about this in other episodes. So you're getting like a lot of metabolic work with no payoff. So overfeeding one amino acid while underfeeding another one isn't neutral. It's actually wasted cost both to you as the consumer paying for it and to the horse metabolically. And it's extra nitrogen the kidneys and the body have to process for nothing, right? And they're going to excrete, as I said, they're going to urinate more expensive bedding. Like there's real cost to this, and it's one of the reasons why I'm always very cautious about people just wanting to throw a single amino acid at that's not how you do this. You don't just supplement one amino acid.
So a good amino acid supplement isn't how much lysine you can cram in it. It's does this actually have lysine, methionine, and threonine together in a sensible ratio to each other?
Yeah, I mean that's the point of a balanced product, right? And where why you see well formulated supplements there, and there are quite a few of them out there, right, they're providing the big three that we talked about, right? They're providing lysine, methionine, and threonine, and they're built around a specific ratio, typically something like 5:3:2, right? Or some similar split where, rather than the product being 95% lysine and a sprinkle of everything else, right? There is, you have to have enough of the other amino acids for it to make a meaningful contribution. And the ratio is doing real biological work. It's not just marketing then in that situation, right? It's also why, so again, like it's my preference, why I would rather somebody feed something with lysine, methionine, and threonine at realistic levels than just go and buy lysine and just feed lysine. It's also why, it's also why, honestly, my bigger preference is that you do use complete protein sources. So I talked about soy earlier, but that's the benefit of soy is that it's a complete protein. It has all the amino acids in it, right? So you're much less likely to screw up the horse's amino acid ratios by feeding an ingredient like soybean meal or say whey protein, because you're going to provide all of the amino acids rather than just one. So you're much more likely to get the results you're looking for.
Can you give us some real numbers? Because I feel like every label just says amino acids, like in big letters, and then a tiny ingredients list.
Or tiny quantities, right? It's a tiny ingredient list with tiny quantities, right? For sure. We don't typically name names on this.
We're not naming names. You're going to call somebody out?
But there's one product out there that just really got my goat when it came out, and it just
we're really going downhill.
I'm still not going to name names. But
okay.
It's disappeared now. I mean, it's still out there, but it was a real fad for a while, and it was just everywhere. And I would look at the label, and it just like next to nothing of any amino acid in it. And I'm like, people are making these wild claims. Well, they made wild claims about what it could do. The people and I'm like, I don't get it. It doesn't make any sense to me. Like
wait a second. Let's not pick on the amino acids. There's all kinds of supplements that are out there that are making wild claims that have nothing in them.
Oh, I know. But I mean, we're talking about aminos today, right?
Okay, so today we're going to talk about the aminos.
This is my pet peeve amino acid supplement. I have plenty of other pet peeve supplements, but this was just like, this was the amino. And I think, the whole time we've been talking about this and putting this episode together, like this one product, I just never understood how it got such kind of like a cult following, and all the things it supposedly did for people, because I'm just like, it doesn't make any sense. There's barely anything in it. But let's go through it. So for lysine, the NRC, the National Research Council, they put a 500 kilogram horse, that's 1,100 pounds, that's at maintenance, right? So they're not working. They're just sort of tootling around, keeping themselves alive, wandering around a pasture type. That's their lifestyle, right? They need roughly 23 to 27 grams of lysine per day as a baseline. And that climbs with life stage and workload. So a horse in, say, moderate work needs somewhere in the high 20s to mid 30 grams per day. Young growing horses, I mean, this is where it's at, right? Like they need 36 to 50 grams a day. And a 2-year-old in, say, race training would be up near 45 grams per day. So you start to see the importance of these essential amino acids to growing animals, because everything you're doing when you're growing is protein, whether it's growing your skeleton, growing longer tendons, growing bigger muscles, like that's all protein, right? So that's why the growing horses have such a demand for protein, and in turn, specifically lysine.
That's a lot more than I assumed. Where did that number actually come from?
So this is like a lot of people, it's not what people assume, right? So the foundational research behind the lysine number was done in young growing horses, weanlings and yearlings, back in the 1970s and 80s, right? So a group of research, really like sort of the fathers of sort of equine nutrition, Dr. Ott and Asquith and Feaster and people like that. And, they were looking at this, and those studies established a ratio of lysine to digestible energy in growing horses that supported healthy growth rates. And so they were the first ones that really figured out what the lysine requirement was in a young growing horse.
So mature horse numbers, working horse numbers, broodmare numbers
were extrapolated outwards from the growing horse data, right? So they were not independently established with their own dedicated feeding trials in each of these groups. And so people might be surprised about that, right? We extrapolated that from the young growing horse data. And it's a reasonable and a defensible way to build a framework when direct data doesn't exist for every life stage, but it does mean the confidence level isn't the same across the board, right? So it's strongest for young growing horses because that's where the actual research was done. And it gets progressively more assumption-based the further away you move from that original population.
Does that affect the crude protein number too?
Yeah, that's actually sort of second to the lysine work, which again, I don't think a lot of people realize. So the National Research Council crude protein requirement is actually built around an assumption that the diet's protein contains roughly 4.3% lysine. So the crude protein number isn't an independent measurement, again, right? It's a back calculation from the lysine target, which outside of the young growing horses was itself extrapolated, right? So if we take the young growing horses, because that's where we had good lysine data in the young growing horses, then we make the assumption that that amount of lysine is 4.3% of the total protein that needs to be consumed, then you can calculate your crude protein number, right? If you have a mature horse, you're going to take the young growing horse's lysine number, make some assumptions and come up with your mature horse's lysine number, and then make the assumption that that's 4.3% of the crude protein, and then you have your crude protein requirement.
You get how crazy this sounds, right?
I know, totally.
Like we're taking assumptions, extrapolating on research that was done on one age group, and then basing it off of... Anyway, I have lots of things to say about that. The NRC guidelines need to be updated. We all know that. There's no money for research. Equine research is slow. Like, there's so many things. And this is just... And then everybody's on Facebook getting upset about what they should feed their horses. We don't even know.
Yeah, I want to know what my favorite amino supplement should be. And it's like...
Whatever your horse will eat. That's the answer, I think. Anyway, no, keep going. Keep going. We've got science. There's some science here.
Yeah, so it doesn't mean that the requirement numbers are wrong or useless, right? They're actually they're carefully reasoned, and they use what's available. It just means that they carry more uncertainty than a lot of people realize, right? And that's why at the end of the day, the most important thing is to be watching your own horse, right? It's why I can have clients who on paper are feeding their horses enough crude protein and enough lysine and still have poor top line or bad feet, or you know what I mean? So it's like, again, you have to look at the horse, and there's the art and the science of feeding, and science gets us so far and we only know so much. And so you have to look at the animal in front of you, and you have to feed the horse that's standing in front of you. And if it's looking like a horse that is telling you it has some protein deficits, then maybe you need to look at the diet and provide some better quality protein and, see how you can go about improving its, amino acid intake. But lysine is still, it is the only amino acid with a formal NRC established requirement of its own. Methionine and threonine don't have an official NRC requirement. So researchers and nutritionists estimate reasonable targets by looking at the amino acid ratios found in horse muscle tissue itself. And then they take the ideal protein approach that we talked about earlier. And relative to lysine at 100%, threonine comes out at about 61%, and methionine comes out at about 27%.
Okay, so if lysine's requirement is around 25 grams a day at maintenance,
you're looking at about 15 grams of threonine and about 7 grams of methionine to stay in that reasonable ratio at maintenance. And climbing from there, obviously, with work and growth and lactation, because with those, the lysine requirement demand increases, and so then the other ones increase as well. So some sources put maintenance methionine closer to 7 to 8 grams a day directly, and that, again, that lines up well with that ratio approach we discussed.
So how do these numbers compare to the supplements everyone's feeding? And to be honest with you, I feed a supplement, an amino acid supplement. I don't know what the numbers are.
Actually, you feed a protein supplement. I would argue that you don't feed, yes, you're obviously feeding an amino acid supplement because, as we've talked about, all protein is amino acids. But the supplement that you're feeding is not just lysine, just methionine, just threonine. What you're feeding is actually a high quality protein supplement. So it's providing all of the amino acids. So yes, it is an amino acid supplement, but you're not just feeding 3 amino acids, you're feeding complete protein.
Okay, but my point is, I don't know how many grams of anything is. I said I need an amino acid supplement or a protein supplement or my horse needs, whatever I said to you, and you said, go get this, and that's what I did. But I'd never actually looked at it. I just trusted what you said.
But that's the beauty of working with an equine nutritionist, is you can just...
That's right. I don't want to know all the numbers. You just tell me and I'll go buy it. But
right.
Anyway, but how do these numbers compare to the supplements everyone's feeding?
Yeah. So again, this is a lot, right? If you don't care about any of this and you just want the results, then find a good nutritionist to work with. But some of the amino acid products on the market, again, it's like we've said before, supplements across the board. It's really unfortunate that there are ones out there that just don't have what needs to be in them, because they're the ones that kind of really drag the whole category down, right? Because there are some good ones out there, and there are some that are dosed at levels to be effective, right? You'll see products delivering, say, 10 grams of lysine, 5 grams of methionine, 2 grams of threonine in a serving. And that's, those are pretty effective levels, right? They're going to make a meaningful contribution towards the numbers we just talked about, especially if you add them on top of a good quality base diet.
And the other end of the spectrum?
That's where you'll find, the amino acid content per serving is measured in a few hundred milligrams, like well under a gram, right? So you might see something like 315 milligrams of lysine. Well, that's great. That's 0.3 grams, right? When you compare that to a target of, say, 7 grams that you might need, it's a couple hundred milligrams isn't going to move the needle. It's not zero, right? But it's not going to do what I can't see how it's going to do what the marketing implies either.
I think that's really important, because there are, we've said this before, you read the analysis and it's in milligrams, it's in grams, it's in percentages. Like, you have to make sure that you actually know the number that you need and then be able to convert it.
Right.
2 grams to actually know if you're actually getting it.
Yeah, because 1,000 milligrams sounds really impressive, right? But that's 1 gram. So it looks less impressive when you put it on the label as 1 gram, perhaps, right? Perhaps people are going to get swayed by, that's a big number, 1,000 milligrams, that's a big number. And then they're comparing it against something that has, 1.5 grams. That doesn't seem quite so impressive, but actually the product with 1.5 grams is providing more than the one that's providing 1,000 milligrams. So you do have to understand, how these metric units work in order to really be able to scrutinize a product.
And this is also why going on Facebook and asking what aminos everybody's feeding, just because they're feeding it doesn't mean they actually work. This is why you should know how to read the labels and understand the guaranteed analysis. I feel like that sounded... Wait a second. I feel like that sounded snarky, so I'm going to take it back. I wasn't trying to sound snarky, but it is really important that you know how to read and understand the guaranteed analysis, because if you're going to spend money on supplements that are so expensive, it's just one more thing that you're spending money on, and you're actually not getting anything out of it, but it's got great marketing, like that doesn't matter. Great marketing only helps the marketer. It doesn't help your horse.
Yeah, and if it's metabolically demanding for your horse to metabolize this thing that they don't actually need, then it's really actually backfiring on you. And I think it's fine to, if you're not aware of what supplements in a category are out there, and you're just curious to, I don't know, for some reason you want to ask a real human instead of asking, AI or Google or whatever, right? Like, what protein supplements are out there for horses? Great. But then go and do your due diligence and go to the, product websites and read the labels and look at the thing. And does it stack up? Does it sound too good to be true? Because if so, it probably is, right? So definitely there are going to be products that just, don't have enough in them to really be effective, right? They're just, and then the other thing, I think this is a good point that I learned a long time ago by fluke was, there are also products out there that will list all the amino acids on the label, which makes you think as a consumer that those amino acids have been added to the product. So you think, this is great. Like, look at all these added amino acids because they're all guaranteed on the label. But then what you find out is, for example, let's say the product is a flax-based product. And it turns out that those amino acid values that they're guaranteeing are the amino acids that are coming from flax, right? They're not being added to the product. They're inherent in flax, which I don't have a problem with. Like, great. Like, you're getting your amino acids from flax, not a big deal. But to me, that marketing is a little bit gray. It's like, it makes people think that this product's adding all these things. The product's way more expensive than just buying flax, right? And people have this misconception that it's better than flax because look at all these, when you just go buy a bag of flax, it just says flax. And it says, protein, fat, fiber, calcium, phosphorus. That's probably all you're going to get on a bag of plain flax, right? You're not going to get any amino acid guarantees on that bag of plain flax. So then you go get the supplement that's, got
flax,
15 amino acids guaranteed on it. And you go, whoa, this is way better than flax. And it must be better than flax because it's 3 times as expensive as flax, without realizing that they've been very clever in their marketing, that they're just guaranteeing you the amino acids that flax just provides. So it's
marketing.
It is. Gotta love it, gotta hate it at the same time.
So what should I actually be doing with this information at the feed room?
3 things, right? 1, flip the tub around and find the actual gram amount per serving for each specific amino acid, like not just collective amino acids, right? That's a vague category. And not crude protein percentage, because that doesn't tell you anything about which amino acids are actually in there. 2, know roughly what your horse's diet is already supplying from the hay and feed that that you're giving. And so, you've done that and decided you have a gap to fill, right? Or maybe you've got a nicely, what looks like a well-balanced diet, but the horse is just like not looking, as good as it could. And you just think maybe a bit more, amino acid support might help, right? But supplementing lysine on top of an alfalfa heavy diet, for example, that's already well supplied is different from supplementing it on top of a straight grass hay diet and oats, right? Like, so you kind of have to know what your base diet is. You probably, if you're feeding a good amount of alfalfa, the chances of your horse being lysine deficient is probably pretty slim. If you're feeding a stemmier, lower quality grass hay, absolutely, your diet might be a little lysine deficient, right? So you have to think about the base, as I always, with all my diets, right? Start with the base diet, and then you add your supplements on top later. Like, don't start with your supplements and go backwards. Like, that's not how to do it, right? So then the third thing is compare the gram number against real targets, right? So for a mature horse at maintenance, you want to see lysine in double digits, not a fraction of a gram. Right. And with methionine and threonine, sort of following the ratios that we talked about, like, so if that's what you're looking for, if you think you're missing some of the, typically limiting amino acids, then you need to find a product that's going to provide those to you in gram quantities.
So it's less, does it have an amino acid, and more, does it have enough of the right ones and the right quantity to actually do anything?
Yeah, right. That's absolutely right. That's the whole conversation here, right?
Yes. Okay. Last topic. BCAAs. I see them marketing, and they're on the labels. I know you said it. We talked about it briefly in the beginning, but Let's go through that one more time. Yeah.
So that's branched chain amino acids, and it's just a structural description of the amino acid, right? So there are 3, so the branched chain amino acids have a branch shape in their side chain. And so if you're looking at the chemical structure, if you've done some chemistry in your life, you'll kind of have a sense of what that means. The branched chain amino acids, we're talking about specifically a leucine, isoleucine, and valine. They're all essential. The horse can't make them. And what makes them a sort of a distinct category worth talking about is that they make up a big chunk of muscle protein, right? Roughly 1/3 to 40% of the essential amino acid content of muscle tissue are branched chain amino acids.
So they're not just another amino acid. They're heavily represented in the actual tissue we're trying to build.
Yeah, if you're trying to build muscle and top line, if that's kind of your issue, absolutely. Right. And there's a second reason they get attention beyond just being the building blocks, is that leucine specifically does something the others don't nearly do as well, right? So it acts as a direct signal that switches on. Okay, so bear with me. I'm going to get a little chemistry biology here, right? Leucine switches on a cellular pathway called mTOR. And mTOR is essentially like the start building muscle protein switch, right? So it's a really important part of building muscle tissue. So if you're trying to build, so for example, if we use the analogy of building a wall and the amino acids are bricks in this case, you're not just supplying the brick. Leucine is actually like knocking on the door, telling the crew to start building the wall, right? Like it's a switch, which really helps with muscle development.
And isoleucine and valine don't do that.
Not nearly to the same degree, no. So in human research, where this has been studied, again, not what a surprise, far more than in horses, right? Because we're very interested in, and again, it's so interesting, like, so backing up, when it comes to sort of lysine, methionine, and threonine, the go-to research for horses outside of horses is like poultry and swine, right? Because that's important there. When it comes to the branched chain amino acids, we tend to go to human research because this is now about building athletic muscle tissue, right? And treating horses as athletes. And so we go to the human literature because there's so much more human literature on managing muscle turnover and building muscle and muscle strength and generating speed, right? And all those kinds of things are very much criteria in exercise physiology for humans. And so there's a lot more work there than in horses. And when the individual branched chain amino acids were examined separately in humans, the stimulatory effect of muscle protein synthesis was attributed primarily to leucine, not isoleucine and valine. So isoleucine and valine are still essential and still get used, but they're not doing leucine's signaling job.
So what does the horse-specific research actually say, or are we relying on human bodybuilding research?
So there is some actual equine research, but it's very limited, and it does, evaluate branched chain amino acid supplementation in horses. And a lot of the claims about recovery, fatigue, body composition, those have been extrapolated from the human work, like I was just mentioning, and also rodent studies. There's quite a lot of rodent studies. So we don't have as much demonstrated work just in horses, but there's been the direct work that we have. There was, like, for example, one study where they fed thoroughbreds 20 grams per day of branched chain amino acids after exercise in a specific ratio of like 2 to 1 to 1 leucine to isoleucine to valine. And they looked at whether it affected the muscle building signaling pathway. And the takeaway from that work was that exercise itself is a dominant trigger for turning that pathway on. The added branched chain amino acid didn't clearly outperform what exercise was already doing on its own. But again, there's very limited data sort of in horses. So we need a lot more work to really definitively say that, to understand how branched chain amino acids are working in horses.
Do we actually need to supplement all three, or is leucine really the one doing the work?
Because the research doesn't give us sort of a clean verdict, it's a little unclear, right? But mechanistically, leucine looks like the one kind of doing the signaling. It's the amino acid that's actually flipping that switch on to encourage muscle tissue to get built. But you can't build the physical muscle protein without the other two. And so isoleucine and valine are still required as, building materials for that tissue alongside all the other 17 amino acids, right? The question is really whether the horse's baseline diet is already supplying enough isoleucine and valine. And if it's a reasonable quality diet with decent forage and say like a soybean meal or alfalfa based feed, it usually already is. Right. So since whole protein sources bring the full amino acid profile with them, not just one piece of it. So again, I come back to my preferences towards feeding what I call complete proteins, protein sources that provide all the amino acids rather than, again, just like targeting individual amino acids. But I certainly have clients whose horses struggle to develop top line that I do targeted specific amino acid supplementation with, say, leucine in particular.
You sort of just answered my next question, which was, what's the good source of branched chain amino acids?
Actually, something I haven't mentioned, so I didn't quite answer that question. Probably the best, probably one of the best sources of branched chain amino acids is whey protein. And that's why you see it in a lot of human workout recovery drinks, and protein shakes, right? Pretty heavy in whey. It's disproportionately loaded in branched chain amino acids. Whey protein, it's not just, a few random amino acids. It's like 20 to 25% of whey protein is branched chain amino acid by weight, right? So that's a lot. And so leucine alone is typically 10 to 14% of that protein, which is high compared to other sources. So a 25-gram serving of whey protein delivers somewhere between 5.5 to 6.5 grams of total branched chain amino acid, with leucine making up the largest single chunk of that. So if you really want to, get branched chain amino acids into a horse's diet, whey protein is kind of the way to go as a supplement.
So if someone's looking for a supplement to support top-line development, are they better off feeding something with whey in it or an isolated source of leucine?
The case for isolated leucine, I know it's I just kind of contradicted myself, right? Because I kind of said I've done targeted amino acid and I've just done leucine before, but whey protein is the more complete way to do that. So the case for isolated leucine around hard exercise is more defensible than, doing all three branched chain amino acids. But I think it's important that, we just don't have the horse trials that we don't have the same confidence in this as we do with, say, lysine, right? The work that we have on lysine is much more solid in horses than knowing if leucine on its own is effective. So it's an area where the science is still developing. And I treat any strong claims by supplement manufacturers in either direction with some skepticism, right? Until there's more equine specific data. Not just borrowed human signaling research, but again, the benefit of a complete protein approach is the peace of mind that you're getting all the amino acids, not just focusing on one. I feel like you're much less likely to mess the amino acid balance up if you rely on complete protein sources than you are if you start cherry picking amino acids. So I occasionally will, find a supplement that just has leucine in it, but I'm pretty confident in how I'm applying it to the diet. I would encourage horse owners to lean more into finding complete protein sources that provide a greater range of amino acids to get the job done.
So that's a pretty different answer than what you see a lot of the supplement marketing, right?
Mm-hmm.
I mean, let's recap this because I want to make sure that it's stuck. So one more time, take the whole episode and recap it for me.
Okay, no pressure. Okay, so amino acids are building blocks of protein, and horses need adequate amounts of the right ones, right? Not just protein in general. And, right, so we talk about crude protein requirements, but actually horses have an amino acid requirement. We just don't talk about that very much. There are essential and non-essential amino acids. There are 10 essential ones, and they can't be made by the horse's body and must be in the diet. Non-essential ones can be synthesized internally, and it's not that they're not important, it's just that the horse can make them themselves. In real-world diets, lysine is the first limiting amino acid, followed by threonine and methionine close behind, and those three are what, most, amino acid supplements are going to have in them, and they're sort of the foundation for most amino acid supplements. Methionine and threonine targets come from something called ideal protein, which is a concept that muscle amino acid ratios are relative to the amount of lysine. And they kind of create a ratio for methionine and threonine based on the amount of lysine. What else did we talk about? Okay, amino acids need to arrive together, right? So they need to be in balance, that there's no point in overloading the amount of protein that you're feeding and the amount of certain amino acids that you're providing. It doesn't buy you more protein synthesis. It just buys you wasted nitrogen, right? And a waste of money. And then branched chain amino acids are particularly useful for muscle protein synthesis. And it's, looking at the human data, leucine looks like it's really the signaling driver for muscle protein synthesis. But isoleucine and valine are also important as building blocks. And What else? Oh, like looking for gram amounts, right? Not milligram amounts that are, in the hundreds, right? If you're looking at milligrams, you need thousands of milligrams. If you're looking at grams, it needs to be, more than a gram to do anything, which unfortunately I think is going to mean that quite a few listeners are going to go out to their feed room and be disappointed when they turn their supplements over and realize that they're not getting gram quantities.
They're not going to be disappointed. They're going to be happy that we gave them the information they need to make smart decisions to feed and supplement their horse. And they're going to go looking and be good consumers and buy a product that actually works.
That's, fair point. I like that. I like that perspective. That's a much better perspective.
Is there anything we forgot that we didn't cover that we need to mention before we wrap this up?
One thing I didn't mention, which perhaps it's just a nutritionist thing, but if you hear people in the nutrition industry talking about protein quality, that comes down to essential amino acids as well, right? So when we talk about a source of protein that, I want a better quality protein, we're talking about the relative proportion of essential amino acids that make up that protein. So that's why when I say that like soybean meal is a really good source of quality protein, it's because relatively speaking, it has more essential amino acids in it than the other protein sources that we tend to use, right? So that's how, when we're saying protein quality, that's what we're meaning. So I just want to clarify that in case people ever hear, conversations about protein quality or us nutritionists throwing around terms about, well, that's a better protein quality source than that. And it's like, what does that actually mean? It comes down to the essential amino acid composition of that protein source.
So I know I said we were going to wrap this up, but I do have one more question. I don't know if it's relevant here, but I'm going to ask it. And if it's not, you can just tell me it's not relevant.
Okie doke.
We talked about whey. We talked about soy. We talked about alfalfa. But I do see pea protein coming up a lot.
Yeah.
Is that valid? Is that something that should happen in this discussion? Does that?
Yeah. I mean,
amino acids
source.
and pea protein. What's going on there?
Yeah. No, it is. We're seeing it in more, we're seeing some of these unique legume-based protein sources, right? Kind of creeping in, especially into feeds that are soy-free, where we're looking for other sources of amino acids. It's, it does have all the essential amino acids, but the biggest problem with pea protein is it's very low in methionine, right? So if you're relying solely on pea protein to provide, to kind of bump up the essential amino acid content of your diet, you're probably going to fall short in methionine. However, where it kind of wins, right? Where what makes leucine pea protein special is leucine. Jumping ahead of myself. So leucine, the leucine content of pea protein, there's more leucine, it's about 8.4% leucine, versus methionine is only at 1.1%, right? So if you're trying to, if you want an ingredient for muscle support, pea protein, can work its way into some of those products for that purpose, because it is a good source of leucine in a complete protein package. But as far as like just making sure you're getting all of the amino acids for a base diet, I would be a little, I'd want to mix it with something else to make sure that I had adequate methionine, because just relying on pea protein would probably leave you short in methionine. So that's where soybean meal is a much better broad spectrum essential amino acid protein source, because it has higher levels of those more commonly limiting amino acids than pea protein does.
For our listeners, if you'd like to be a part of our conversation, please send your suggestions for future topics and equine nutrition questions to info@scoopandscale.com, and is spelled out. You can also find Claire at clarityequine.com.
We know that if you're like us, you're probably listening to this while driving or doing barn chores. But when your hands are free, if you'd share it with your friends on social media, and be sure to subscribe on your favorite podcast platform, it helps other horse lovers like you to find us.
For the Scoop and Scale podcast, I'm Jill Jackson.
And I'm Dr. Claire Tunis.
Thanks for riding along with us.